Hello there, this is an Algebra 2 video. It's Chapter 4, Section 8. It is the last section of the chapter, and it is over quadratic inequalities. And we've been graphing quadratics since the beginning of this chapter and have done it in a couple different ways. So you are welcome to graph your quadratics in whichever form you'd like. You can transform them into vertex form if you want and graph them that way. Or you can graph them using the t-table, which is what I'm going to be using today. But there was a little bit of a difference in this section than there has been in the previous. Obviously, we were graphing quadratic equations before with equal signs, and now we are graphing quadratic inequalities. And as you probably can imagine, whenever you deal with inequalities, you have to deal with shading and dashed versus solid boundary lines. So to remind you, basically greater thans typically mean you're going to shade above the boundary line, or in this case inside the parabola if it's facing up. And if it's a less than, you'll generally be shading outside of the parabola, again if it's facing up. And then of course, if it's a greater than or a less than, you want the boundary line to be a dashed line. If it's a solid, if it's an equal to, less than or equal to, greater than or equal to, then you want to make it a solid boundary line. So let's get started here. The first thing I want to do is find the vertex. So I'm going to go negative b divided by 2a. So in this case, my b value is 2, my a value is 1. So I'm going to get basically negative 2 divided by positive 2, which is negative 1. And then I want to plug negative 1 into the equation to get the y coordinate. So I'm going to go negative 1 squared is positive 1. 2 times negative 1 is negative 2. And then I have my plus 1. So I get 1 plus 1 is 2, and 2 minus 2 is 0. So my vertex is going to be negative 1, 0. And then I want to pick two other points so that it can be symmetric, right? So 0 comes after negative 1, and negative 2 comes before negative 1. So we've got 0, negative 1, negative 2 in that order. Plugging in the 0 is going to be nice and easy, because when I go 0, 0, it's going to be 1. So I'm going to have 0, 1, and I'm going by 1, 2, 3, 4, 5, 6, 7. So 0, 1, x is 0, y is 1. And also negative 2, 1. And since my graph is a greater than, not an equal to, I need to make my parabola boundary a dashed or broken parabola instead of a solid line. Okay? Now, I said before that if it's a greater than, in general, you're going to be shading on the inside if it's facing up. And if it's less than, you'd be shading below the boundary, which is out here. But in case you're not sure, you can always use our method from before, which is to test the point. The origin is the easiest point to test, so the first thing you want to do is locate it. It's right here, so that we know that it's on the other side of the boundary line. So either it's inside the parabola or it's outside the parabola. In this case, it's outside. And then you want to see if it gives you a true statement or not when you plug in 0 and 0 for x and y. So if y is 0, and if x is 0, you get this statement, because we already know that when x is 0, y is 1. So the question is 0 bigger than 1? And 0 is not bigger than 1, which basically tells you that that's a false statement. So you don't want to shade the area where the origin is. You want to shade away from where the origin is. So for our shading, we basically get the area inside the parabola. Alrighty, and that is how you graph an inequality, pretty much. Pretty basic, okay? So now you want to try do-it-yourself number 1, A and B. Keep in mind that this guy is going to have a dashed boundary line, and this guy is going to have a solid boundary line because it has an equal to. Alrighty, so then we're going to go to solving quadratic inequality. Now we're not graphing it, we're solving it. So the difference here is that now you have your standard ax squared plus bx plus c, And instead of it saying y, it's a 0, okay? So again, I want to show you the two scenarios. You can either have ax squared plus bx plus c is less than 0. Now remember, what we're doing is we're replacing the y with a 0, which is the same thing we did before where we're trying to find the roots of the equation. They called it before, the zeros of the equation. So we're doing the same thing. So basically you want to know where are all the y values that are less than 0. Where are the y values that are less than 0? Another way of saying that is, where are the y values that are below the x-axis? Because below the x-axis, this is the y-axis here, and it's below the x-axis, and this is where all the y values are negative. So basically, all of this portion of the graph is where the y values are negative. But notice that even though we're talking about where the y values are negative, you're going to solve for x. So you want to know what x values are going to give you y values that are negative. So you basically want the x values that are represented by this red portion here. Everything in between these 2 points, and these are the zeros, anything in between these 2 zeros is going to give you a y value that is negative. Anything that is outside of those 2 zeros is going to give you a y value that's positive. This point here, this x value here, will eventually give you a positive y value. And we want negative y value, less than 0. So below the x-axis, you want this red portion here. However, if the parabola was flipped, which it could be negative x squared, then that would be the opposite. Then the y values wouldn't be in between, because these are positive y values. They would be outside the x values. And the same is true in this case. If you wanted to be greater than 0, then you're looking for the x values that are the y values that are above the x-axis. So if you wanted them to be greater than 0 in this case, obviously the in-between would be the negative y values. The outside would be the positive y values, which would be these two pieces here. And then if the parabola was flipped, the positive y values would be in between the 2 zeros. Alrighty, so we're going to be using that information to actually solve this equation by graphing. Alright, and the first thing we want to do when you solve an equation, an inequality like that, is to basically find the zeros, because we know that the zeros are actually the places where the graph equals 0. So this is a little bit easier. We can do that by factoring. And if you can't factor it, you could always use the quadratic formula, but I think I can factor this little guy. We want to do 4 times 2, and it needs to be a negative 8 and a positive 2 here. So I think if we do this, we can get negative 4. Nope. I'm totally backwards there. We want a positive 4. So 1 times 4 is positive 4, and 1 times negative 2. 4 minus 2 is 2, which is that there. And positive 4 times negative is negative 8. So now we have our factored, and we get x plus 4, x minus 2 equals 0. So we know that x equals negative 4 and positive 2. Alrighty, so when we graph this little guy, it's really simple. It doesn't have to be exact. We're just looking for the, we don't have to know the vertex for this. All we have to know is the zeros and which direction the parabola is going. In other words, here we have 1, 2, 3, 4, negative 4, and positive 2. So we have 1 0 there and 1 0 at negative 4. And because this is a positive x squared, we know that it's opening up. So the parabola looks like this. Now again, I'm not exactly sure what the vertex is here, but it's irrelevant. We don't need to know what the vertex is to solve this equation. All we're looking for is where are the y values that are less than 0, the negative y values. And those are going to be all the y values that are down here. And those are going to be in between the 2 zeros. So our strategy here is to basically find the 2 zeros, graph them, know which direction the parabola is opening, so that we know whether it's inside the 2 zeros or outside the 2 zeros where the answers are going to be Okay, so in this case, we want to write our answer in set notation. So we're going to say that the values are going to be all x's such that x's are between -4 and 2. And that's how you write your solution in set notation. Notice that I didn't put equal to's because this didn't have an equal to, so I'm not including the -4 and the 2. If it said less than or equal to 0, then we could put equal to's here, and we would include -4 and 2. But we're not including -4 and 2, just everything in between -4 and 2. All right. So that is how you do that. So now I want you to try to do this do-it-yourself question. But keep in mind that you want to put this in the right order. This is saying 0 is bigger than x squared plus 5x minus 6, which would be the same thing as saying x squared plus 5x minus 6 is smaller than 0. So the 0 is on the wrong side there. That might help if you do that. Okay, so now we're going to go to example 3. And example 3 is like I was saying earlier. We can't always factor the problem. So in this case, it's the one that we can't factor. So, but I still need to find the zeros. So I'm going to go x equals -b plus or minus radical b squared is 16 minus 4ac all divided by 2a. So I get 4 times 2 is 8, and 8 times 5 is 40. And since these are both negative, that's a plus 40. So 40 plus 16 is 56. So what this tells us is that the square root of 56 is not an actual perfect square. So we're going to get some crazy decimals here. So let's figure out what they're going to be. You're going to get -4 plus the square root of 56, and then divided by 4. And you're going to get approximately 0.87. Then you're going to get -4 minus the square root of 56, excuse me, divided by 4, and you're going to get approximately -2.87. Okay, now there's still, again, we said earlier, I'm not really interested in exactly where the vertex is. I just need to know where the zeros are, and I need to know whether or not this graph is opening up or down. So, I'm going to go 1, 2, 3, 1, 2, maybe we need to keep going a little further. 1, 2, 3. Okay? So what's happening here is I got 0.87. If this is 1, then 0.87 is roughly right here somewhere, close to 1 but not quite there yet. And -2.87 is close to -3 but not quite there yet. So those are my two zeros. And then I have that it's positive. It's a positive 2x squared. So it's going to be opening up. And furthermore, it says greater than or equal to. So my graph is doing something like this. Again, I'm not exactly sure or don't really need to know what the vertex is. I just need to know what these values are and that it's opening up, because if I want the y values to be greater than 0, I am looking for this piece here and that piece there. I need the x values that will give me those results. Now, keep in mind that this time, those results aren't going to happen in between the two zeros. They're going to happen outside of those two zeros. So my answer is going to be all x's. Sorry about that. All x's such that x is either less than or equal to -2.87, or x is greater than or equal to 0.87. Okay? So in this case, it's not an intersection, it's a union. So either they're going to be less than negative 2.87 or greater than 0.87. Alrighty, and that's how you write that solution. And so then you have two others to remember that in these cases you're going to want to use the quadratic formula as opposed to the other way. Okay? Sorry. Here we go. Example 4. So now I'm going to kind of give you a little bit of a trick here, which I've kind of already alluded to in the past. The first thing we have to do is make sure this is a 0, and it's not. So we're going to first do that. X squared minus 3x minus 18 less than or equal to 0. Believe it or not, you don't actually have to graph the function if you have an understanding of the different intervals where your solution would fall. Either it's in between the two zeros or it's outside the two zeros. So we can actually do this algebraically by using what we call test intervals. And that's what I'm going to show you how to do now. So the first thing you have to do is obviously find the zeros. Whether you find the zeros by factoring or the quadratic formula, doesn't matter, but you have to find the zeros. So I'm going to factor because I believe this guy is factorable, and 18 is going to be 6 times 3, and then I'm going to go negative 6 and positive 3 because 3 minus 6 is negative 3, which is what that is, and negative 6 times positive 3 is negative 18. So my factorization is going to be x minus 6 times x plus 3 equal to 0. Remember, I'm finding my zeros. So I get x equals 6 and negative 3. Now what we call these little guys is basically critical numbers. And what these numbers are going to do is they're going to divide your number line into 3 separate intervals, okay? So just imagine, if you will, you don't have to keep drawing this number line every single time. But for the first time, I want to show you how it works. You want to put these numbers on your number line in chronological order. So somewhere you have a negative 3, and somewhere you have a positive 6. So you can see what I mean by 3 intervals. Your 3 intervals are going to be this interval, and that interval. Okay? So what you'll want to do is take those intervals and put them over here. So we're going to go. Now when you say this interval, this is basically negative 3 and beyond. So that's negative infinity. So we're going to go negative infinity to negative 3. My next interval is going to start at negative 3 and go until 6. And my last interval is going to start at 6 and go forever to positive infinity. Okay? And these brackets are not like ordered pairs. You're not going to graph negative 3, 6. It's an interval. It gives you some boundaries between here and here. Okay, if this was a bracket, it would mean that it was included, but we're not talking about including anything right now. So we have our intervals, excuse me, and then what you do is you take the 2 factors that you have over here, okay, well, actually, we don't have to do that part because it's not always going to be factorable, so I don't want to do that part. But what you want to do now is basically you're going to test the interval. So what you have to do is find a representative that's from each interval, somebody that is within that interval. Don't pick the actual number. So for example, in this case, because I'm going from negative to positive, 0 is in that interval. 0 is in between negative 3 and 6. You don't have to pick 0, but if you can, obviously 0 is an easy number to pick. A number that's in this interval is 7 because it's 6, 7, 8, 9, right? Over here you can pick negative 4. I always try to pick the integer that is closest to the actual number without actually picking the number, okay? So those are my representatives, and then I test them. I test them to see if they give me a positive, a negative, or what. So I'm going to test the negative 4. So when I plug in negative 4, I'm going to get x squared. That's going to be negative 4 is going to be positive 16. And then negative 3 times negative 4 is positive 12. And then minus 18. Okay? So 16 plus 12 minus 18 is going to give me a positive 10. That's a positive number. When I plug in 0, that's easy. 0, 0, I'm going to get negative 18. So here I'm going to get negative 18, which is a negative number. And then 7 squared is 49. And then minus 3 times 7, which is negative 21, and then minus 18. So 49 minus 21 minus 18 will give me 10 again, and that's a positive number, okay? So basically what this tells me is that this interval is all positive y values. This interval is all negative y values, and this interval is all positive y values. Now what were they actually asking for? They wanted less than or equal to 0. So they wanted negative values. So the only interval that gives me negative y values is this interval here. And so that is my answer. I don't have to graph anything. My answer is, and you can even say x such that x is less than or equal to 6, but greater than or equal to negative 3. Because in this case, we know that it's an equal to up here, so we can include the endpoints. So we can write it like this, but it's actually a lot easier to just write it with the intervals. This means the exact same thing. You use brackets when you have equal to's, and you use parentheses when you're not including the endpoints. Okay? So either one of these would suffice for your answer for that example. So now we are going to let you do these do-it-yourself questions, and once you have done those, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.